Today we'll be learning how to graph solutions to two-step inequalities. Let's first talk about how to graph solutions on a number line. Here I'm given the inequality x is less than 6. Since my value is 6, let's start by putting a circle on 6 on the number line. Since the inequality states that x can be less than 6 but not equal to 6, we're going to leave that circle open to show that 6 is not a solution to this inequality. Now let's find the other values that are less than 6 on this number line. All the values on the left side of the number 6 are less than 6. You can even imagine that as the number line continues down to negative infinity, all those negative values are also less than 6. So we'll draw a line to the left of 6 with an arrow to show that all those values satisfy this inequality. Now let's change this inequality to x is less than or equal to 6, and think about how that would affect our graph. The inequality states that x can be less than 6 or x can be equal to 6. If we plug 6 in for x in our inequality, it reads 6 is less than or equal to 6. Since 6 is equal to 6, this inequality holds true and 6 will be a solution. We show that on our graph by filling in the circle at 6, like this. And again, we find all the values that are less than 6 as well, drawing an arrow to the left. Let's start our first full example. We're given the inequality 1 plus 3k is greater than or equal to 10. Remember, solving two-step inequalities is very similar to solving two-step equations, in that we can isolate the variable by performing operations on both sides. To solve for k in this inequality, we'll need to use inverse operations to get k by itself. So to start, we'll want to cancel out the 1 on the left side of the inequality. We can do that by subtracting 1 from both sides of the inequality, like this. When we simplify, 1 minus 1 is 0, and we're left with just 3k on the left side. On the right side, 10 minus 1 gives us 9. Now we are still trying to isolate k. Since 3 is being multiplied by k, we will need to divide by 3 on both sides in order to cancel it out. When we simplify, on the left side, 3 divided by 3 is 1, and we're left with just k. On the right side, 9 divided by 3 gives us 3, making our final answer k is greater than or equal to 3. Now it's time to graph our solution on the number line. Since 3 is included in the solution, we will start by filling in a circle at 3. All other values greater than 3 are represented to the right of the 3 on the number line. So we'll draw our arrow to the right to show all those values that are solutions to this inequality. For our second example, we're given the inequality negative 2b plus 12 is greater than 18. Again, we'll use inverse operations to solve for the variable. We'll need to start by subtracting 12 on both sides. Doing that cancels out the 12 because 12 minus 12 is just 0. So we're left with negative 2b on the left side. On the right side, 18 minus 12 gives us 6. So now we're looking at the inequality negative 2b is greater than 6. We'll need to divide by negative 2 on both sides to isolate the b. That leaves us with just b on the left side and negative 3 on the right side. But wait, there's one more thing. Recall that any time you multiply or divide by a negative number on both sides of an inequality, you need to flip the inequality symbol, like this. We do that in this inequality because we divided by negative 2 on both sides. So my final answer is b is less than negative 3. Now we can graph. We'll start with an open circle at negative 3 on the number line to show that negative 3 is not a solution to this inequality. Then we'll draw our arrow to the left because the values to the left of negative 3 are all less than negative 3. For our third and final example, we're given the inequality 1 is less than or equal to t over 2 minus 4. To start, we'll need to add 4 to both sides of our inequality. On the left side, 1 plus 4 gives us 5, and on the right side, negative 4 plus 4 cancel each other out, leaving us with just t over 2. Since we're still trying to isolate t, and it is being divided by 2, we will need to multiply by 2 on both sides. Should we reverse the direction of the inequality symbol? No, we are multiplying by a positive number, not a negative number, so we don't have to flip the inequality sign. 2 times 5 on the left side gives us 10, while our 2's cancel out on the right side, leaving us with an inequality of 10 is less than or equal to t. Sometimes it's easier to graph inequalities when we have our variable written on the left side of the inequality, like this. 10 is less than or equal to t is the exact same as t is greater than or equal to 10. Now let's graph. We'll start with a closed circle at 10 because 10 is a solution to this inequality. Then we're looking for the values that are greater than 10, which appear on the number line to the right of 10, so we'll draw our arrow to the right. Graphing solutions to two-step inequalities combines a lot of prior knowledge of solving inequalities and graphing inequalities. Keep up the good work.